All right, guys. So, in this video, I'd like to start out here with a warm up question, kind of like I've been doing. Just for some warm up and review, feel free to pause the video and try this. We were talking last time about dividing polynomials. Today, we're going to talk about how to use that in order to graph. But as a warm up, let's try this: 2x cubed minus 11x squared minus 9x plus 20 divided by, let's try x minus 6. Let's see if you can figure that one out. So you can pause the video here and you can try that one if you'd like. All right, so I'm assuming you paused the video and gave this one a shot. This one I can use synthetic division because this is linear and it has a leading coefficient of 1. So I'm going to go ahead and put a 6 in the box right here. And then across the top, I'm going to put all of these coefficients. I do not skip anything here, so that's good. I'm going to put a 2, a negative 11, a negative 9, and a 20. And remember how this process works. You got to get the hang of this process because we're going to use it a lot. 2 times 6 is 12. Add in the middle. Negative 11 plus 12 is 1. 1 times 6 is 6. Add in the middle, I get negative 3. 6 times negative 3 is negative 18. Add in the middle, and in my final box here, I get a 2. If I'm going to write this answer, this was an x cubed. So down here, this is going to be an x squared. And then we decrease in power from there. So this is going to be 2x squared plus 1x minus 3 plus my remainder, which is 2, divided by my divisor, which was x minus 6. Okay, so here would be my final answer to this division question right here. Now, if I came over here and I asked you, is x minus 6 a factor of 2x cubed minus 11x squared minus 9x plus 20? So this would be a great quiz type question here to ask just to see if you're understanding the ideas. We would have to say no, because it does not divide evenly. Okay, it does not divide evenly. All right, in order for something to be a factor, it has to have a remainder of 0, and in this case, it does not have a remainder of 0. So therefore, it's not a factor, but that doesn't mean that we still can't do the math with it. Okay, so that's just a quick review of what we were doing in the last video with synthetic division. Let's move into an example here where we'll talk about some graphing. Okay. All right. So here's what I'd like us to try. For our first function, we're going to try f of x equals 2x cubed plus 5x squared minus 28x minus 15. Okay. All right. And our directions here are going to be, let's see if we can graph this function. All right. Now, I want to begin by something that's incorrect. So do not write this down on your paper, but I want to show you. A lot of students will look at this first off and they'll say, okay, there are 4 terms here. So let's see if we can factor this thing by grouping. Okay. Well, if I look at these first couple terms, I can take an x squared out of them. Okay. And if I take an x squared out, there would be a 2x plus 5 left over. And then if I look at these next 2 terms, I should begin by taking out a negative. But between a 28 and a 15, there's nothing in common, so I could take out a 1. So I'm really taking out a negative 1. And if I flip the signs, this gives me 28x plus 15. Okay. Now, using correct mathematical sense here, we should say, hey, this cannot be factored by grouping. Cannot be factored by grouping because I don't have the same thing in both sets of parentheses. So if we're just using normal factoring tactics here, this cannot be factored, okay? Because it's not a quadratic, it's not a difference of perfect squares, and when I try factoring by grouping, I don't get the same thing in both sets of parentheses. So using normal factoring tactics, at this point, we would be stuck, okay? There's nothing else that we would be able to do. So that's where I'm going to extend this problem a little bit and say, what if I told you that x equals negative 5 is an x-intercept of f of x. Okay, what if I told you that x equals negative 5 is an x-intercept of f of x? So what that means is the big jump in thinking right here, and you got to be able to make this connection in order to do this problem any further. If you think about how we find x-intercepts, what we do is we take the factored form of the function, we set it equal to 0, and we solve for x. Well, if the factored form of the function being set equal to 0 and solving for x gives us an answer of x equals -5, then what that means is when we factor this, this has to be x plus 5 times a bunch of other stuff. That way, if I set this equal to 0 and I solve for x, one of my answers that I get is going to be -5. Okay, so extending this thinking just a little bit further. So if I know that part of the factored form of this function has to have an x plus 5, what we can then ask next is we can say what would happen if we divided f of x by x plus 5. Well, if something is a factor of the function, if we divide by that factor, we should get a remainder of 0. Okay, unless I lied to you when I told you that it was an x-intercept. As long as it is an x-intercept, when we divide by the factor that causes that x-intercept, we should get a remainder of 0. If this confuses you, think about numbers. Let's pick a number like 32. Okay, so let's say I told you 8 is a factor of 32. Okay, which it is. So what this means is if I do 32 divided by 8, I should get a number. In this case, I get 4 with a remainder of 0. Okay. The only way I would get something that does not have a remainder of 0 is if it's not a factor. So, like, for example, 6 is not a factor of 32. So, therefore, if I divide 32 by 6, I should get something that has a remainder since it's not a factor. And in fact, 32 divided by 6 goes into 32 5 times, but there's a remainder of 2 left over when I'm done. And since there's a remainder, it is not a factor. Okay. So again, to recap, if I'm telling you that x equals -5 is an x-intercept of the function, that means that in its factored form, I would see an x plus 5. And if that's a factor of the function, then if I divide the function by that factor, we should get a remainder of 0. Now, how does that apply to the graphing? Well, what we're going to do to go any further with this graph is we're going to divide by x plus 5. Okay. So in other words, what I'm going to do here to start out is I'm going to take my function, which is 2x cubed plus 5x squared minus 28x minus 15, and I'm going to divide by x plus 5. Okay. So what does that mean? Well, if I divide by x plus 5, remember that means I'm going to put a box, and I'll put a -5 in the box. Okay. And then I'm going to write my coefficients across the top. So that's going to be 2, 5, -28, and -15. Now again, I'm looking for a remainder of 0. If I don't get a remainder of 0, one of two things happen. Either you messed up your math or I lied to you when I gave you the problem. And I can assure you that I'm not going to lie to you when I gave you the problem. So if you don't get a remainder of 0, it means you did something wrong. Now, one thing that I like to keep track of off to the side here, if I write this -5 in the box, I'm going to put an x plus 5 so that I remember, hey, I am dividing here by x plus 5. And we'll talk about what to do from there when I am finished with my synthetic division. So let's go ahead and give this a shot. So I'm going to bring down this 2. 2 times -5 is -10. Okay, add in the middle, I get -5. Multiply by the box. -5 times -5 is 25. Add them, I get -3. -3 times -5 is 15. And as I expected, I got a remainder of 0. Okay, so let's take a moment to collect our thoughts. What have we figured out so far? Well, we just figured out that this function is x plus 5 times whatever I got here is my answer. If I multiply those two things together, that should give me the original function. Okay, so if we think about our answer here, this was x cubed, so this has to be x squared, so this is going to be 2x squared minus 5x minus 3. Okay, and just to check off to the side, you don't have to do this, but I'm only going to do this once. Let's try this. X times 2x squared, that's 2x cubed. X times -5x, that's -5x squared. X times -3, that's -3x. 5 times 2x squared, that's a plus 10x squared. 5 times -5x is a minus 25x. And 5 times -3, that's a minus 15. Let's put all this stuff together. I got 2x cubed. Okay, negative 5x squared plus 10x squared, that's a plus 5x squared. Okay, negative 3x minus 25x is a minus 28x. And then I have a minus 15 left over, and that, you'll notice, is the same thing that I had right here. So that is checking out. So by doing this division, I was able to get this thing down to a little bit simpler of a version. And the reason why I'm saying that is because check out this thing right here. This is a quadratic. We do know how to factor quadratics. So the last thing that I'm going to do for this problem before I can have the completely factored form and start graphing is I got to factor this quadratic. Now, do not forget about this x plus 5 right here. Okay, that x plus 5 is not going anywhere. So let's go ahead and let's make sure that we write that down. So I've got an x plus 5 sitting right here. Okay, and then let's try and factor this quadratic. So remember, if there's a 2x squared at the front, I'm going to put a 2x and a 2x. Okay, and then I'm going to do 2 times negative 3, so that's a negative 6. Two factors of negative 6 that add up to negative 5 would be negative 6 and positive 1. So I'm going to go ahead and write those numbers down, negative 6 and positive 1. But keep in mind, I have to divide a 2 out of one of these sets of parentheses. And in this case, I can divide a 2 out of this middle set of parentheses. So this is going to be x plus 5 times 2x minus 6 divided by 2. That's going to be x minus 3. And then times 2x plus 1. Okay, and when I'm done, that is my completely factored form of this function. Okay, so what you notice here is we took something that could not be factored by grouping, and by me giving you one little tiny piece of information, we were able to do some synthetic division, get this thing down to quadratic remaining in the last set of parentheses, and we could factor quadratics all day, and then we end up with a completely factored form of this function. Okay, so by knowing how to do synthetic division, we can factor things that maybe we had no idea what it looked like before in its factored form, and we can do the division and we can get to that point. All right, let's do some graphing here. So multiplicity. Okay, 1, 1, 1. Multiplicity is 3. This function is positive. Let's see if that checks out. At the very beginning of this whole process, was this thing positive? Yes. Did it have a multiplicity of 3? Yes. So everything is checking out here as I go. And I'm going to go ahead and stop this video right now, and then I will pick it up a little bit later because the doctor just came in the room. Thanks, guys.